To start this lesson, we're going to review simplifying expressions with this quick pull and with this warm-up. So pause the recording long enough to get this done, and we'll go over it when you return. Okay. Most students did really, really well. Let's go over this for those watching the video. Make sure that you did as well as the students in class. When we're trying to simplify this expression, we simplify using the order of operations. And I see these grouping symbols, and I know I can't combine x tiles with unit tiles. So I can't simplify what's inside of the parentheses. But as I'm looking inside the parentheses, I do see subtraction, which I do prefer to rewrite as adding a negative. So since I can't simplify what's in the parentheses, those parentheses must be there for another reason, and it's because we're multiplying across those parentheses. We have 5 of these groups. That means 5 groups of 2 x tiles is 10 x tiles, and so I'm going to include that plus sign. 5 groups of 3 negative unit tiles, 5 times a negative 3 is negative 15. And then we can finish up by bringing down this plus 2x because we're not done with the problem there. And now I can see I've got like terms to combine. 10x and 2x will combine to give me 12x. And we don't have anything to combine here, so we still have those plus and negative 15 unit tiles. Other students chose to write it as 12x minus 15, and that is still perfectly acceptable. So nicely done. Now we're on to the Notice and Wonder. We're going to be talking about Unit 4, Lesson 1, number puzzles. So what we did yesterday with our anchor problem with the chocolate, that was kind of an introduction to equations that have a little bit of extra stuff going on than just the 2-step equations that we have seen. And that is that's what this lesson is talking about too. Equations that are disguised as just riddles and number puzzles, but they're equations that have a little bit extra going on. And if we disguise them as riddles and number puzzles, then it makes it a little bit more interesting than just doing the same old boring 2-step equations. So we're going to start here with this Notice and Wonder. You guys already had a chance to talk with your groups. Tell me now, what are some things that you notice? We're going to focus just on the notice, not what we wonder. What do you notice? Sam? Okay, that's a great thing to notice. We notice that we've got a bunch of arrows up here, and just one arrow down here. These look like an unsimplified version of this, which looks like a simplified version. Good connection. Yes, Hayden. Yes, there is only one arrow that is going towards the negative side. Very good. Good thing to notice. What do you notice, Luke? Yes, there are arrows. That is a very basic thing to notice, but good job on noticing it. Let's finish up with the last 2 hands. Maverick. Yeah, we did stuff like this last year. We did stuff like this last year when we were talking about adding integers. Yeah, and so we had positive integers, negative integers. We represented how to do that on the number line. Really good connection to past learning. Tage. Good, very good. What do you wonder? Anything that you wonder? Lance. Great. Taking this very abstract representation and wondering what it means quantitatively. We see this dot on 12, but what does it represent? Great connection to the math practices there. What other things do you wonder? Do you wonder how these arrows relate together, or did you all notice that they were related based on what Sam said earlier? Did everyone notice that? Anyone wondering it now? They are all connected. Let's look at how they're connected. Do you see this arrow that starts on 0, goes down to -4? The red arrow picks up where it left off and is going up here to 3. And this arrow picks up where that one left off and goes all the way up here to 12. So just like Sam said, we can do that a lot simpler by, instead of backtracking and doing it in multiple steps, we can just start at 0 and go to 12. So what I want you to do now, will you write an unsimplified expression? It'll just be a numeric expression. There's not going to be any x tiles involved here. But write a numeric expression to show all of these little baby steps, and then simplify it to show how we can do that in just one single step. I'm going to pause the recording as you guys work on that with your groups. Ready, set, go. All right, what does this represent, Emery? You wrote it down what, sorry? You can write it down as an equation. What would we have on one side of the equation? Good. -4, because we can see that this first blue arrow goes from 0 to -4. Keep going. +8. Why 8? Double check. You're really close. 1, 2, 3, 4, 5, 6, 7 is how long that one is. So can we change it to +7? Okay, good. +7. And then what? Do you want to finish, Emery, or do you want me to call on someone else? +9. Why 9? Yep. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is how long that arrow is. So +9. And you said you set it up as an equation. So this is an expression, but you can say this expression is equal to the simplified version of this, which is 12. Very good. This is kind of like a number puzzle that we're going to be looking at disguised as arrows, a little bit of a riddle that we need to solve. And that's what we're going to be doing here. I want you to solve each puzzle showing your thinking. Don't move on to the second one until you've done the first one. We'll probably interrupt you partway through so we can go over it. But whatever you do, you need to organize how you're showing your thinking so others can follow it. So instead of you having to describe it, you can just say, here's my paper, look and see what I did, and they can follow your thoughts. The first puzzle is this. The temperature was very cold. Then the temperature doubled. Then the temperature dropped by 10 degrees. Then the temperature increased by 40 degrees. After all of those changes, the temperature is now 16 degrees. What was the starting temperature? Any questions on how to get started? Do you all have a plan? Okay, follow that plan. When you're ready, you can also move on to number 2. Number 2 is Lynn ran twice as far as Diego. Diego ran 300 meters farther than Jada. Jada ran 1/3 the distance that Noah ran. Noah ran 1,200 miles. How far did Lynn run? So, with your groups, I don't want anyone to move on to number 2 until everyone in the group has completed number 1. If you're watching the video at home, complete 1 before you move on to 2. Pausing the recording. Ready, set, go. All right, Sam, how did you organize your information? Yeah, a flow map is a great way to organize this information because we can see we don't know where we're starting. We're starting with a very cold T for temperature. Notice how I'm drawing my T. If I'm going to use T, if you want to use X, that's fine. But T, if I just do a T like that, it looks like a plus sign. That can be very confusing. So I make the T the same way that the computer makes the T, that type font lowercase t with a little curve on it. Okay, go ahead and make that flow map. What is happening to this temperature? Emery, go ahead. Yep, it's doubling first, multiplied by 2. And then what's happening to that temperature? I should see the other hands right now too. Even if you didn't build a flow map, you can follow along. Temperature is very cold, temperature doubled. Dean? Yep, it dropped 10 degrees, so we minus by 10. Good. And then what happens to the temperature after that, Charlie? We add 40. Temperature increased by 40 degrees. And all of those things make the temperature now be equal to 16 degrees. So if you want to solve this number puzzle, we just have to undo those things. How do I undo the temperature increasing by 40 degrees, Fitz? Okay, but we're doing this model right now. Luke? We subtract 40. And how do I undo the temperature dropping by 10 degrees, Porter? It increases by 10 degrees. So see how this flow map can be really helpful tool besides just those solving equations? Even just thinking through this riddle here is helpful. Gabe, last one. Divide by 2 to undo the fact that the temperature doubled. When I do those things with the temperature, that's what happened with the temperature, and I track it, and now I can undo those things. I'm going to know what the temperature is. So you don't necessarily even have to turn this into an equation because it didn't start off as an equation. You can just follow the flow map. Starting at 16, let's subtract 40 degrees. 16, subtract 40 degrees. Thank you. Add 10 degrees. Negative 14. Divide by 2. So what was the temperature in the beginning? Negative 7. The temperature was indeed very cold. Now, I had some students, when I looked at their papers, instead of making a flow map, they recognized that they could represent this with an equation that they could just easily solve. So who wrote an equation and what does that look like? Good. Danielle. Okay, good. Great. That's perfect. And here is one advantage to writing the equation like this too. Do you recognize that you have two like terms that you can combine? Instead of undoing the plus 40 and then undoing the minus 10, you can just combine these like terms. So that is one really cool thing about writing that equation. You can combine two steps into one. I'm just curious, anyone who wrote an equation, did you do that? Okay, we had two who did. The rest of you who wrote your equation, did you just undo it step by step? Okay, either way, it's going to work the same. Notice that we're going to go through the same steps that we did in our flow map, but I like seeing that we can represent this with an equation. We can subtract 40 from each side, giving us 2x minus 10 is equal to negative 24. Now we can add 10 to each side, giving us 2x is equal to negative 14, which we can then divide. I have to come all the way up here. Divide each side by 2, and that's how we get x is equal to negative 7. Same result, just different thought processes, and both are great. So as we work on number 2, see if either of those methods are going to work. In my opinion, I prefer a completely different method, which is making a model. So see if that can help you in any way, shape, or form. Let's go another 2 minutes working on this problem with your groups, and we're pausing the recording. Ready, set, go. All right, when I walked around the room, you guys figured this out in ways that my brain couldn't even handle, so I'm really impressed. But I also want your brains to grow. So I want to show you the way that I did it, also because it makes a connection to what you're going to be seeing in your cool down and your homework. So I want to make your mind grow by seeing another way that most students didn't think of. I'm going to draw a diagram for this. And so when I draw this diagram, hold on, I think I need to adjust a setting. Lynn ran twice as far as Diego. So I am going to use this information right here. This is going to represent what Diego ran. So when I'm trying to represent what Lynn ran, I'm going to use 2 of these bars to show that that is twice what Diego did. Will you include this in your notes just so that you can see another way of doing the problem that relates to something that you're going to see again later on? So Diego, I don't know exactly what he ran, but it's that amount. Lynn ran twice as far as Diego, so I did 2 of those boxes stacked right next to each other. And then I see Diego ran 300 meters farther than Jada. So now here's how I'm going to represent what Jada ran. I'm going to use that same box as Diego, but notice the issue with using that same box. Diego ran further than Jada, right? So I have to get rid of some of that box to show Jada actually didn't run that amount. Diego ran 300 meters, so the amount extra is, that amount there is 300 that Jada did not actually run. I also know that Jada ran 1/3 the distance that Noah ran. So I'm going to draw a little box here now that represents what Jada did actually run, so that I can move that on down. So that's what Jada actually did run, but Jada ran 1/3 the distance that Noah ran. So here's how I'm going to represent Noah. I take the actual smaller, shorter box that Jada ran, and I'm going to do 3 of those. And I use this information to then see, hey, Noah ran 1,200 meters. So this amount is 1,200 meters. So then I can start kind of working backwards through that diagram. This is 1,200 meters. That means 12 divided by 3 makes each one of these 400 meters. But remember, that box is the exact same as what Jada ran. So now I know that this that Jada ran is 400. But remember, Jada ran 300 meters less than Diego, so the 400 plus the extra 300, that gets us to what Diego ran. So now I know Diego ran 700. And this box is 700. There's 2 of them to represent what Lynn ran. Lynn ran twice as far as Diego, or 2 times 700. Lynn ran 1,400 meters. Just wanted to introduce that sort of visual diagram, not the same as X tiles and unit tiles and things like that, but kind of a bar model or tape model sort of diagram, just because you're going to see that later on and I want you to be able to recognize what it's showing you there. This next one, I'm going to make it homework, not complete homework. This is part of the homework. It says you need to now write a number puzzle with at least 3 steps. It says on a different piece of paper. If you have enough space, you can just do it in that space. If you don't feel like that's enough space, do it on a separate sheet of paper. On a different piece of paper, write a solution, which means maybe on the front side of your paper, you're going to do your number puzzle. On the back, you're going to write the solution. Just because I don't know if there is enough space here. Later on, tomorrow, we'll trade puzzles with the partner to solve this. We can't do that at home. So part of your homework is you writing that puzzle, and then we'll trade those puzzles in class tomorrow. Any questions on the expectation for that one? Okay, let's finish up. I really, really, really like this one. This Are You Ready for More? You will probably want your calculators here. I want you to think of a number, any number at all. If you are smart, I would probably keep it like an integer. Probably don't do something like pi. It's going to make it kind of crazy. Okay, so just because we're going to be doing some calculations, don't go crazy with it. Think of a number, any number. Everyone have it in your head. Okay, double the number. You can use your calculators if you need to. Add 9. Now subtract 3. Now divide by 2. Now subtract the number that you started with. Your answer is 3. Should we try it again? Should we try it again? I know I got it. Should we try it again, you picking a different number? Let's break the system, right? Did you use your calculator? Did you type everything in your calculator correctly? Okay. Try a different number. Pick a different number. Let's do this again. Use your calculators. Use your calculators. Each time you use your calculator, you need to make sure you calculate. So think of a number. Now double the number. So you're going to do times 2 and then enter so that it will actually calculate. Now add 9 and press enter so it will actually calculate. Now subtract 3. Press enter so it will calculate. Now divide by 2. Press enter so it will actually do the calculation. Subtract the number that you started with. Press enter and now your answer is 3. No, it is not possible to make it so it's not, and here's the reason why. Why does this always work? Will you please have a quick conversation with your table? Why does this always work? And then we'll talk about the math behind it. We're going to pause the recording as students talk. That way it gives you a chance to think as well. Okay, why does this always work? Jamie? Yeah. There's other stuff, but Jamie noticed we're doubling the number, and then eventually at some point we're dividing by 2. What's going to happen? Yeah, that's going to kind of undo itself. So that's kind of why this is going to be happening. Maverick, other thoughts? Exactly right. So this is how this works. Eyes on the screen. Think of a number. Everyone's going to come up with a different number, so we can use a variable to represent that. What's our first step? We double it, so we multiply by 2. Then we add 9. Then we subtract 3. And after I do all of those things, so all of those things have to happen first, and then I divide by 2. And then after I divide by 2, we subtract the number we started with. That number we started with is x. So let's start simplifying all of this stuff. Do you see these like terms right here that we can combine? What's 9 minus 3? All right, so this can simplify to 2x plus 6, which is all then divided by 2, and then we subtract x. This is the same as saying 2x can be divided by 2 and also 6 can be divided by 2. What's 2x divided by 2? 2x divided by 2 is just going to be x. And what's 6 divided by 2? So if I have x plus 3 and then I subtract x, what are you going to be left with every single time? So that's exactly right. We disguised it by doing a few other extra things. We doubled, we did some things, we divided, but I disguised it in there, but it is in there. So this x and this minus x are always going to undo each other, leaving us with always just a 3. Kind of cool, right? Try that with your parents. Try that with your family members at home. Make sure they have a calculator. They're going to need it, but try it with them. And let's summarize. As we summarize, here's an example of a puzzle problem. Twice a number plus 4 is 18. What is the number? There's lots of different ways that we can represent it and think through these problems. We can just use reasoning. I kind of like to consider this a flow map where we track what happened to it so that we can then undo it. We can draw a diagram. We saw this with our second example in the lesson. And we can also write an equation, which is something that we have been building towards for a long time. So this is a natural progression. So reasoning and diagrams help us see what is going on and why the answer is what it is. But as number puzzles and story problems get more complex, those methods also get a bit harder. So equations become more and more useful. The good thing with the equations, we can still continue to use flow maps. The flow maps are going to continue to help. But that is the one thing, all of these riddles, all these number puzzles can be fun and they can be interesting, but equations are going to be a better way to think about them as they get more and more complex. We're going to use different kinds of diagrams to help us understand problems and strategies in these future lessons, but all of those will build to show that the power of writing and solving equations is going to be an incredibly helpful tool. Let's just finish up here with this cool down. That's why I wanted, on number 2, I wanted you to focus on that model because we see that model here in our cool down as well. Andre and Elena are reading the same book over the summer. Andre says he has read 1/5 of the book. Elena says she has read 20 more pages than Andre. If Elena is on page 55, how many pages are in the book? Lynn has this diagram drawn in order to answer this question, but there is an error. Will you find Lynn's error? Pause the recording until you've had a chance to look at this and think about this. So if Elena is on page 55, this amount accurately represents what Elena has read. We can also see that Elena has read 20 more pages than Andre, so we're going to reduce that bar length by 20 to show Andre, and all of this is accurate. The mistake in this diagram is Andre has read 1/5 of the book, not Elena. So what I should do is take the amount that Andre has read, which is significantly smaller than what Elena has read, and that's the part of the diagram that we should have represented by 5 of those bars. So this is Andre, which is 1/5. If I multiply that by 5, you can see it is the correct length. And we know that this length, 55, minus that 20 pages extra that Elena has read, that gets us to an amount of 35, which we then have 5 of those pieces. So 35 multiplied by 5 is equal to 175 pages. Again, it's going to be hard to find the error in this diagram if we don't know how to draw those diagrams to begin with, which is why I spent the time doing that on that previous problem. Your homework is let's see, we've already done the cool down, so it's not that. Scroll on past that. This is the homework. I skipped a couple problems, had to rewrite some, so it looks kind of weird, but we're doing problems 2 through 7 as part of your homework. And I also wanted you to write your own number puzzles so that we can share those with the class tomorrow. So that's your homework. That's it for today. Thanks for watching.